Lean manufacturing is about reducing or removing waste from within a system or process. It's safe to say then that lean companies only make enough products to meet real customer demands. Therefore, no inventory of finished goods is maintained. A pull-based system of production and distribution is demand-driven rather than forecast-reliant. A pull system basically limits the amount of work in process, WIP, that can be in the system at a given time. Replenishing of supplies or production is determined according to actual customer orders that have been received. The sale of that product has already been negotiated. A pull environment will come from real demands and products only made to satisfy real orders. A work item can only be in process if there's a demand for it. This environment can be found or set at any level within an organization. We can visualize it on the production floor as well as in the flow of information between departments. A pull system is a control-oriented system that operates by receiving signals that more production is needed. There are two different types of pull systems, sequential and replenishment. Sequential pull is where the downstream personnel pulls parts from the upstream supplying process in the sequence in which the prior step produces it. Sequential pull limits the amount of inventory between the two steps of a process. The ideal output is one-piece flow. When we refer to one-piece flow, we mean that sub-assemblies are moved from step to step, one piece at a time, or a small batch at a time, minimizing work-in-process inventory. Replenishment pull is where the downstream personnel pull parts from a storage location according to what they need to complete their tasks. This is like how a supermarket works. So replenishment pull systems are also called supermarket systems. The parts removed from the storage location, or supermarket, are replenished by the supplying process. Lean uses a concept called Kanban, meaning signal in Japanese, to manage this type of pull system. Kanban uses cards to signal and communicate the need for more supplies. In the context of the flow of information, a pull system allows employees to pull their next task if they have the capacity to start working on it. This helps them to better prioritize tasks and prevents overloading, helping employees stay focused on executing the work. Let's visualize a couple of examples that would represent manufacturing pull systems. When standing at a workstation along the production line, we notice that there's only one footprint for the subassembly, which can be placed between Station 3 and Station 4. This is limiting the amount of work in process that the operator at Station 3 can produce. Upon removal of the subassembly by the operator at Station 4, the empty footprint signals the operator at Station 3 to replenish the subassembly. This controlled condition clearly represents a pull system in place. Another case would be when a box of components is being consumed and a card, a light, or other signal prompts material handling to bring over another box to ensure no interruption to the workflow. A pull system triggers the action only if the WIP limit has been reached. In this case, the WIP limit is met when half the box of components has been consumed.